have both?
Yeah, please move forward.
Okay. So hello guys, my name is Minko, and today I'm going to be talking about scalable application architecture. So we're going to talk about generic architecture and how it can be applied in an Angular application in this case. A few words about me. For the last couple of years, I'm working with a venture capital company called Learn Capital, and we're developing different products in the companies in their portfolio. The latest product that I started working on is Brownie Points, and it has quite dynamic requirements, so the architecture that I'm going to present is partially inspired by this project. A few words about me. So I'm quite active in the open source community, especially in this part of it that is doing Angular. And I just finished my first book, switching to Angular 2, where my technical editor is Gechev, the creator of Angular, so the content should be all right. I mean, it should be technically correct. You can take advantage of this discount code if you are interested. It will give you 50% off. The agenda for today, well, basically we are going to put some constraints which are common for the products for most startups, and we're going to develop an architecture around these constraints. Before that, well, it doesn't work. Before that, let's explain what architecture actually is, because the boundary between design and architecture, it is kind of blurry sometimes. According to Martin Fowler, architecture, these are all decisions that are hard to change, and everything else should be considered as design decisions. So story time, a couple of maybe weeks ago, I started working on another product in a company from the portfolio of Learn Capital, and as in more startups, and as in most startups, this product has a dynamic set of constraints. For instance, it has very dynamic requirements. So you're building a startup, you have a lot of competitors, and you want to satisfy the users' requirements as better as possible, and you want to beat your competitors. And unfortunately, you cannot rewrite your front end every 6 weeks because, well, that's just not how it works. You need to build a solid base of your application, and you need to extend it somehow and keep the open-close principle at least. Also, we have scalable communication layer, and this is something common for most startups as well. What do I mean by this? Well, we have the regular RESTful API, which is the one that most single-page application communicate with. We also have real-time communication through WebSockets, and we have WebRTC data channel between the individual peers. And based on these differences in the communication layer, we have various package formats that we are exchanging. So for instance, in the RESTful API, we are using JSON, which is something common. For instance, in the WebSocket application service that we are communicating with, we are using remote procedure call because, well, we have duplex communication layer there. And RPC is quite natural fit. And for WebRTC, for the WebRTC data channel, we want something that is going to make the payload of the package that goes through the network as small as possible. So we bet on something binary there, and this is BERT RTC. How many of you have heard about BERT? Well, it is a binary protocol that GitHub uses internally, so it's quite efficient. Well, we have also multiple state mutation sources. What do I mean by this? So you can think of the state in the context of Redux, for instance. You have a huge immutable state, and it could be modified by user interaction, for instance, or by any of these external services. They can send commands, and respectively, you're going to convert them into actions and apply the set of reducers over your store. So in order to make the state management more predictable, we bet on architecture, something like Redux. And we also hope that we're going to have scalable teams. A lot of the companies in the portfolio of Learn Capital, they are successful, so we hope that we are going to be one of these companies one day, and our team is going to scale. This means that we cannot write code that nobody can understand. We need to write something that is easy to get even by junior developers, and they will become productive from the beginning. And of course, lazy loading is another important part when you're building a huge single-page application. So this is another constraint that we had in mind. Basically, these are the constraints that we have. And let's take a look at the first three. Dynamic requirements, scalable communication layer, various package formats. Basically, you can handle all these three by using a simple practice from software engineering and computer science, and that's abstraction. Well, for instance, we have WebRTC and WebSockets. Well, these two protocols on fundamental level, they're quite different because WebRTC, it is peer-to-peer communication protocol, right? However, in WebSockets, you have a centralized architecture where there is a server and the individual peers connect to this server and communicate with it. However, in the same time, they're quite similar as well. You can create an abstraction called gateway, and this abstraction is going to have a data stream that is going to receive messages from, and also is going to be able to send messages through it. So you can write your code with this abstraction in mind, and basically you can include different implementations of this abstraction, and your application is still going to work. So you will not have to rewrite it every 6 weeks. The mutable states, the multiple state mutation sources, well, they can be handled with something like Redux, where you have predictable state management. And the scalable team and lazy loading, you can make your application just modular. And here is an example. So here we have a directory structure of game which has single player and multiplayer modes, and as well it also has a home screen. So you can divide, you can spread among your team members this application the following way. So one of the team members can take shared. He should be more experienced because he needs to be familiar with all the architectural decisions. Another team member can take home, 30-member single player, and after that multiplayer, the fourth one. And when the user opens home, you need to load home and shared, of course, because the shared these are all the code units that are shared among the other pages. And this way, you're going to load only the functionality that the user needs. Same for single player and for multiplayer as well. So the sample tech stack that I'm going to use in order to explain the architecture, this scalable architecture that I'm going to talk about, is Angular 2, RxJS, and NGRX. NGRX is Redux-like implementation on top of RxJS and Angular 2. How many of you are familiar with RxJS, have used it? OK, so we are going to make a short introduction to the technology as well. And we're also using TypeScript. Well, I personally love functional programming languages, purely functional languages even more, like Elm or ClojureScript, which is not that pure. But it is super hard to find developers who are familiar with these languages. And if you are in San Francisco and you pay $300,000 salary per year, maybe you will find such developers. But well, then probably you don't need to build that startup because you already have a lot of money. So we bet on TypeScript, which brings a standard syntax familiar to most people who have used imperative languages like Java or C#. And it also has static typing. So in contrast to ECMAScript 2016 and 2015, it has static typing, so you have compile time type checking, and you have some safety when you are writing your code that you haven't made a typo somewhere. And for handling the immutable state and immutable action payload, we are using Immutable.js. So let's explain RxJS in 2 slides. How many of you are familiar with higher-order functions from functional programming? Awesome. So you know what is going to be output of this code, basically. Can someone share the result? Yeah, I heard 4, 6. So first, we're going to apply the higher-order function, the callback of map over 1, and we're going to get 2. And 2 is not bigger than 2, so it's not going to be included in the end result. After that, we are multiplying 2 by 2, and the result is going to be 4, which is bigger than 2. And 3 multiplied by 2 is 6, so the end result is going to be 4, 6. The problem with this approach is that we have fixed array, so we cannot append new elements to this array and apply this set of higher-order functions over this, only over this new element. What we should do is to append the new element. If we live in purely functional world, we're going to get a new array, and we need to apply the entire set of higher-order functions over this array. But with observables, we get something more. Basically, here we create an observable using the factory function create, and we pass a callback to this factory. The callback accepts an observer, and this observer, it can emit new values. Basically, we are creating a new interval inside of the callback that we pass to create, and on each second, we are emitting a new value. Basically, if you have used Haskell or Common Lisp or whatever, you should be familiar with the concept of infinite lists. Basically, RxJS is nothing new on the horizon, but just have a fancy name. So each second, we are emitting a new value. And we can use the observable the following way. Basically, we apply the same set of higher-order functions plus one more called subscribe. So first of all, on the first second, we are going to the observer is going to emit the value 0. We're going to apply map over 0. We're going to get 0, which is not bigger than 2. So we're not going to print the result. After that, we're going to apply map over 1. 1 multiplied by 2 is 2, not bigger than 2, so nothing is going to happen. With 2, so 2 multiplied by 2 is 4. It is going to pass the filter condition, and it is going to be printed onto the screen. Basically, that's the typical flow of what is going to happen in these observables. But the cool thing is that this could not be an interval. This could be a WebSocket stream or something like that. So you can just apply some set of higher-order functions over different values which are gotten from a network stream. Or it could be even local stream, just emitting the store. Why not? And in order to explain the concepts of the architecture better, application that is called Quick Typer. Basically, you can practice just quick typing inside of the app. You see some text, and you start typing it inside of the text box. Once you make an error, your text box is going to get read. Once you complete your challenge, you're going to see how long did it take you to complete it. I'm super slow typer here, 16 seconds. And it also has a multiplayer mode where two players communicate together through WebRTC data channel. And once player A starts typing something into her text box, player B is going to see the output. And same when player B starts typing something into the text box. Once any of the players completes our challenge, the other player is going to lose, and so respectively the first player is going to win. So what architectural approach I used here? Here is the high-level architectural layered diagram. Basically on top, we have a set of UI components. These are the UI components that you're familiar with from Aurelia or from Angular 2 or React. Basically nothing that complex. These components, they may have some local state, but you need to be very careful what you put inside of this local state, and you should carefully consider whether this is a state that should belong to the actual immutable state of the application. After that, the UI components, they communicate with the facade. This is the standard facade pattern that is known from the Gang of 4 book. And the facade, in this context, we're going to call it model, because, well, it is going to abstract the state management and the communication with asynchronous services. The state management is basically a redux. We have a store, we have a set of reducers. We're responsible for managing the store somehow. And once the store changes, we propagate the change to the view layer. And we have asynchronous services. The asynchronous services are everything that has an asynchronous API. Basically, the asynchronous services, they could be just a RESTful API or a WebSocket service or even IndexedDB because it has a synchronous API as well. Let's start with the UI components, which are on top. This is mostly a pseudocode. It's not a real implementation of Angular 2 component because we are missing some important pieces. But it is only to get the main idea. So our UI component, it accepts as argument in its constructor the model which is responsible for handling the entire business logic on user action when something happens inside of this component. So this is the game component, and it uses the game model. Once the user starts typing something, we are invoking the change handler, and we are delegating the further execution to the game model. And that's it. So we have very dummy components without any complex logic inside of them. And they're a perfect start for your junior developers to start working on your app, for instance. Now let's take a look at this facade, at this model. The game model, it has a constructor where it accepts the store. This is the store from, we can think of it as the store from Redux. And it also accepts a set of asynchronous services. And also notice that the store, the model, it has a property called game, which is observable. This is an observable stream of all the changes that happen in the store. So once we change the store somehow, we are going to emit the store through this observable here. And this game $, $, means that this is an observable. This is a convention that we follow when developing NGRX apps. It emits immutable values. And we are initializing it this way. We can think of the store as set of immutable values. And here we are selecting the game part of the store, which is responsible for holding pieces of data which are represent the actual game. And inside of the complete method of the game model, we encapsulate all the business logic which is required to be executed once the user completes typing inside of the text box. Basically, first we create an action called, in this case, it is going to be a complete complete game action or something like that. And these actions, they're a communication protocol inside of our app. Basically, they have meaning only within the boundaries of our application. In the individual components inside of our architecture, they're communicating through these actions, and they know their semantics. Also, we are dispatching this action by using the store. And once we dispatch the action, it is going to be handled by the reducers. And we invoke all the synchronous services with this action. We are going to take a look at these synchronous services just in a moment. The important piece here is how we are using the store. Basically, the store provides an observable which emits new values when the store changes. And we are also dispatching actions by using the store. And now let's take a look at the state management. Basically, that's how the state management happens. Once an important event happens in the component, we are delegating the call to the model. For instance, when the game starts, we are invoking gameModel.startGame. Once we invoke this piece of logic, the model is going to create a new action, and it is going to dispatch this action by using the store. And once we dispatch the action, we are applying all the different reducers associated to the store with this action and the actual store. And this is an example for reducer, basically nothing more than what we already have in Redux. So the reducer, it accepts an argument, the state, which is an immutable state, and the action. Based on the action type and the action payload, we are performing some actions, some logic over the state. For instance, when we create a new game, we are just creating a new immutable object. When we receive an action that the game should be marked as invalid, we're just setting the invalid flag to true. And in the end, we're returning the store. And that's it. In the end, when the reducer all the reducers have been combined and have returned the common store, what we do is just to call next on the observer, which is responsible for emitting new values for the observable, which is the actual state. So we are emitting a new value, and this value gets handled by the component, and that's it. Basically, we get here, this is already the component. We emit new value. I mean, game dollar emits new value, and we are applying the higher order function map, scan in this case, over the new value. Scan in RxJS is something like reduce, but with slightly different semantics because we are talking about observables, not arrays. Thanks to the AngularJS, Angular 2 asynchronous filters, asynchronous pipes, we can pipe the observable value, and we can just take the value that it wraps out of the box and just use it inside of the hide directive. Well, that was about the state management. Now let's talk about the synchronous services. This is the last piece of the architecture, and the synchronous services are the piece of logic which understands both the actions that we are using as communication protocol within the boundaries of our application and understands parts of the API of the remote service. So it creates this bridge here. Right, this is the abstraction of the asynchronous service. Basically, the asynchronous service has nothing more than a single method called process. It accepts an action. It should map this action to a command which is understandable by the remote service, and it returns an observable. So this is the most complex piece of code in the slides. Basically, this is the implementation of the peer-to-peer asynchronous service, which makes the mapping and the communication layer for the peer-to-peer connection between the players inside of our game. And its method process, it is quite simple because we take the action that have been passed by the model and we map it to a command which is going to be serialized and sent through the network. That's it. Basically, the synchronous services, they're mapping actions to actual commands to the actual, which are going to be executed into the context of the remote service. And we're using the WebRC data stream here. And inside of by subscribing to this data stream, we're transforming the binary commands that we receive from the other peer by mapping them to JavaScript objects. And after that, we're just invoking actions, which are handled by the reducers. That's it. Well, but what happens if the game model, it communicates with two services, S1 and S2? The game model creates a new action because something important into the application happens. And it passes this action to S1. S1 modifies this action, and the model passes it to S2. Well, in this case, we're going to have an issue which is hard to debug mostly because it is based on mutability of the states. And well, this means that we need to make the payload of our actions immutable. But one of the main reasons to bet on TypeScript was because of its static typing. However, here it is going to be hard to apply static typing because the keys of the map, they are strings. And well, our IDs and text editors cannot be very smart, helping us with auto-completion, for instance, for the name property of the map. Well, so we don't have static typing in this case. And now we should choose whether to use immutability or static typing. But actually, we can have both. Well, we can approach this way. For instance, we are defining an interface called iUser, which defines the shape of the payload of our action. How many of you are familiar with the records of Immutable.js? OK, well, basically the records, they're, again, factory functions, which as arguments accepts an object literal. And this object literal contains key value pairs, which are setting the default values for the objects that are going to be created by using this record. Basically, a record, it returns a class or a constructor function. It depends on the context. And once we create an object using this constructor function, the object literal that we have passed to record is going to be used for the default values. Basically, since this is a constructor function, we can just use it inside of our user class, and we can extend it. So our user class, it defines the API of the user. It defines that the user has ID, has gender and has also an email address. And by using the record, we are making these fields immutable, since the record is going to return a constructor function. And when we create instances of this constructor function, these instances, the setters of these instances are not going to be enabled. So this is how we have immutability and static typing at once in this sample architecture. Yep. And in order to make a quick recap of the entire flow of data, let's take a look at this diagram. Well, it looks kind of complex. There are a lot of arrows and a lot of boxes, so we're going to take a look at step by step. First, the user fills the registration form and clicks sign up. This means that the sign up form control, it is going to invoke the user model by calling its method sign up with the specific piece of data, which is the actual paywall required for user registration. Using an action creator, the user model is going to create a new action, and it is going to pass the action to the RESTful asynchronous data service. So far, so good. The synchronous data service is going to map the action to a command which is understandable by our RESTful service, and we are going to invoke this command through the RESTful gateway. The RESTful gateway is going to return a result, and this result is going to be propagated all the way back to the data model, to the user model here. And the user model, based on the result, is going to decide whether the user have been successfully signed up or not. If the user have been successfully signed up, it is going to dispatch a new action to the store, which is going to be handled by a reducer. The reducer is going to return a new user object, and the observable user dollar is going to be propagated all the way to the sign-up form. OK. So this is how we have predictable state management, because we have a single store of immutable data. We also make our application testable, because in this case, at least, we are using the dependency injection mechanism of Angular 2. And also, our business logic is entire in reducers, which are pure functions and easy to test. We also haven't coupled to any remote services, because all we are using is only the abstraction called asynchronous service. So we can easily implement it for another asynchronous service and just include it into the application. We haven't coupled to any message format, because the asynchronous services, they are responsible for mapping our actions to remote commands. And we also can use different services based on the context into which the model have been used. Basically, this is something more like Angular specific, because we are using multi-providers, and we can inject different set of asynchronous services to the model based on the context it is used in. And we also have easy management of asynchronous events, since we are using RxJS in this case. So we have all these properties. And you can take a look at the resources here. Basically, if you're not familiar with Redux, I would recommend you to get familiar with it. NGRX is something that Rob from the Angular core team developed. It's pretty cool, and basically follows the exact same rules that Redux sets. And I wrote a blog post about this approach, so you can take a look at it as well. And the demo application, there is a link at GitHub to it. Yeah, thank you very much for your attention.
Thank you. Thank you. Thank you, Minko. Вопросы? Hey.
Hello. I have a question. Maybe I didn't understand you correctly, but I saw that async service changed the store. Is it true?
It just emits new message, and the set of reducer got applied over the store with the past message.
Yeah. So how the model knows that store is changed and something is changing?
The model doesn't use the store at all. It's when the store have been changed, a new value through the observable gets emitted to the UI.
Oh.
Yeah.
Okay.
And this happens. Yeah, this was an important. When we were developing this architecture, it was an important decision whether we should use whether we should dispatch this action inside of the synchronous service or inside of the model. But since the model, it doesn't know about the set of asynchronous services it uses, we thought that it is going to be more logical to put it into the synchronous service itself, because it knows about the remote commands and it can easily map it to an action, and after that just dispatch this action and delegate the logic to the reducers.
Hello. Thank you for great lecture, first of all. And I have a question about languages. Do you have examples for other languages? Not only for TypeScript, in your book, I mean. Not only for TypeScript, for example, for ECMAScript 6, for Dart.
So in the book, basically the ECMAScript 2016, where we have decorators. So the Angular core team is talking with TC39, and most likely we're going to have parameter decorators in ECMAScript 2016 as well. So the examples between ECMAScript 2016 and TypeScript, they're going to be almost the same. I have examples with TypeScript and ECMAScript 5.
Okay, thank you.
And with Dart, I don't have any.
Hi, Minko. I'm here.
Where? Ah.
Hi, Minko. Thank you for presentation. And I have one general question. As I said, that at the moment still is a problem to find experienced developer that knows even Angular 4 and will use all techniques that will provide ability to create stable and testable Angular 4 application. And now we have Angular 2, and we have still we doesn't know release date for Angular 2, and selection of Angular 2 as application-based framework now is very risky decision because we haven't have a stable framework architecture, we haven't stable set of modulars, we have problems with router and so on. So, do you believe that Angular 2 will have same popularity as Angular 4, or Angular 2 is a wrong step in Angular evolution?
Yeah. Well, even if I think that it is a wrong step, but I don't. Basically, they're using it in Google AdWords right now, and they have implemented at Google. They have implemented very huge application with Angular 2. I'm using it for, well, the process of writing the book. It was kind of painful because I had like maybe 10 breaking changes during writing the book, and I needed to go back and forth in order to fix them. However, for the last 6 months or 5 months, there are no breaking changes at all. Even the router is quite stable. I've heard that they may introduce changes in the router. Maybe the biggest problem is that there are no well-established practices for developing Angular 2 applications yet. But it is based on the same idea on which most modern web frameworks are based on. Basically, React and Aurelia and whatever, they all have component-based user interface. The only difference is that in Angular, you get the complete decision, the complete web stack that you need. You have router there, you have dependency injection, you even have support for progressive applications, you have everything you might ever want to need, and it is supported by a single core team at Google, so you have great integration between these individual modules. And I think that Angular 2 is going to get much more popular and much more usable compared to Angular 1 and any other framework on the market. Just that's what I think right now.
Yeah. One small remark. Could you guarantee that when Angular 3 will become, then application-based framework-based architecture will not be changed in the same way as in current?
Yeah, this could be changed. Basically, the Angular 2, it has evolved based on the requirements of the web. When Angular 1 was developed, we didn't have web workers at all, and we didn't have web components, and Angular 1 just doesn't support these things. But if you think, well, React doesn't support them neither, so maybe it is more likely to have a React 30 or whatever compared to Angular 3, because Angular, it already supports the bleeding edge features of the web, optionally supports them, like Shadow DOM. and web workers, but all the other frameworks are a little bit behind. So I think that it is, for near future, we will not have new version of the framework. But well, the web is going to evolve, so we might have one day.
Thank you.
Any question? Any
Question? Oh, yeah. 4 line.
Hello. What do you mean, or what more difficult problem Angular 2 solves in compare with Angular 1?
Yeah, so static typing helps a lot, but you can achieve it by using TypeScript with Angular 1 as well. You have this unidirectional data flow, which helps you basically mostly like what are the advantages of Angular 2 over Angular 1, right?
Yes.
Yeah, well, you can also, it is also not coupled to the DOM as Angular 1 was. Angular 1 is very coupled to the DOM, and this way you cannot write a proper server-side renderer, or even you cannot run your application in web workers. Basically, Angular 2 is based on the web standards. Angular 1 is not, so you can painfully use it with web components. And there are many benefits of Angular 2 compared to Angular 1. The dependency injection is entirely new and has much more features. Yeah, also the performance. Angular 2 has super fast change detection. Basically, they use code generation. They generate a lot of your application runtime. And this way, they enforce a lot of optimizations which are made by the virtual machine, like inline caching, mostly. So it is super fast, really.
And one more question, please. You said that Angular 2 brings the full stack, as you said, of technologies. So
For the front end.
Do you think you can design the scalable application without Redux, for example?
Yeah, I've used Redux because I like functional programming, but you can do everything just using only object-oriented concepts. And if you think of Redux, well, the store that you have, it is almost the same as the repository pattern that we have from the object-oriented programming. Like there is a very popular book by Martin Fowler, Architecture of Enterprise Architectural Patterns. And we have a repository pattern there, which is exactly the same what the store is in Redux, except that it is not immutable.
Why doesn't Angular 2 implement this repository pattern that we can just use
in
the whole stack?
Yeah, they don't want to be that opinionated about this. They even don't want to put you in the boundaries on what language you should use. So they want to let the developers choose their architecture by their self.
All right, thank you.
Hi, thank you for your presentation. I have two questions. First of all, about scalability. So we see current application, and for example, we need to implement authentication or user permissions, and how do you see this implementation in time?
Yeah, well, the most common way to implement authentication right now, authorization, is by using JWT, and all Alt0 are working, well, they're working with any framework, but they already have implementation of JWT with and secure HTTP with Angular 2, which only adds a single header with the JSON Web Token. So I would use JSON Web Token. That's what we are using right now.
I mean, if result of authentication can change access to different modules, for example. So you can have access for one game, but don't have access to another.
Yeah, well, most of the logic should be server-side because the users, they can manipulate basically the JavaScript. So it should be server-side mostly.
Okay, and question number one about the growing team. So if team grows means that it's harder to release because there are too many changes in different places. And have you tried, I don't know, split application into different repositories or something?
Yeah.
What your experience?
Yes. So for ngconf, which is going to be in Utah next month, in the beginning of next month, we're working on Angular 2 style guide, where we're introducing a concept of lazy loading boundaries. And usually these lazy loading boundaries, they don't have any intersection between each other, only the shared directory that I showed. And I'm working, actually our team is pretty small right now. We are only 4 developers. And two of them are working on the front end. Each of them takes individual bounded context. And we had only one merge conflict, I think, in package JSON. So even a single repository should work well when we're following these lazy loading boundaries well enough.
Yeah, but it's hard to release everyday changes because you have to don't affect different places. I don't know, just to have time to release all features independently.
Yeah, you should put strict boundaries. Who can touch what? Yeah, that's it.
Thank you.